I'm now, this is part 2 of 5 of a talk about event attribution, and this is going to talk about natural or anthropogenic, picking on the ideas in part 1. So back to this 2010 Russian heat wave that we saw in part 1. The literature that was published on it had apparently contradictory statements. So here's our hot block. So Dole et al. Writing in 2011 GRL, wrote the intense 2010 Russian heat wave is mainly due to natural internal atmospheric variability, while Ramsdorf and Kumo 2011 Proceedings of the National Academy of Science wrote, we estimate an approximate 80% probability that the 2010 July heat record would not have occurred without climate warming. Those statements seem apparently contradictory. So in one, we have a statement that it was mainly due to natural internal climate variability, and in another that it appeared in it was 80% that it wouldn't have occurred without climate warming. So are both true? Did one make an error? Our journal's not really doing a good job of peer review. No, they are contradictory, but they are both true. So let's go and explore why that is. So here is from a very nice paper by Otto et al. 2012 GRL. Here's our Ramsdorf statement, mainly externally driven from Ramsdorf, and here's our Dole intensive, mainly internally generated. So here's the monthly temperature equivalent in our two scenarios. So we have the 1960 to 1969 period. These are based on models. This is the distribution. This is the return time. So for example, we have a return. The 1 in 10 year event is approximately 22 degree monthly temperature. The 1 in 100 a year event in 60 to 69 is roughly 24 degrees, is coming close to 25 degrees. And I'll mark them up as 10%, 1%. Here is the world from 2000 to 2009, again based on models. And what we might say is, okay, the shift in temperature, which is what Dole et al. Were worrying about, is this small gap here. So it's shifted by 1 or 2 degrees, basically. And so, yes, to get the 25 degrees, the normal conditions are down at 19. That's the average. That's a 1 in 2 year event. Then we'd say, okay, that's a simple shift, but still most of it is internally generated. This is the amount that you're bigger than the normal conditions. Well, Ramsdorf and co are looking at this line going from it being basically a 1 in 100 event to 1 in 20, so 1 in 30 or so, so three or so times increase in risk. And they conclude it's mainly externally driven. So in effect, it depends how you cut the cookie, how you look at the question. So not impossible without warming is true, because it's a 1 in 100 year event, but certainly a lot more likely. So that's one way of thinking about it, but relatively small shifts in the distribution, which is what this is characterizing, can lead to quite large increases in probability of exceeding damaging thresholds. So continuing that discussion, so the July temperatures in 2010 were about 6 degrees above normal, of which about 2 degrees can be blamed or attributed to warming since 1960. So in terms of magnitude, the event was indeed mostly natural. But very likely mostly anthropogenic from our last IPCC report, warming that occurred since 1960 has increased the probability of an event of this magnitude from 1 in 100 years to 3 in 100 years. So in terms of probability, it could be argued the event was mostly anthropogenic. These are two complementary aspects of an event, not mutually exclusive. And these reflect the importance of specifying precisely what question is being asked when you're attributing individual weather events to external drivers of climate. So this is why we will stress with you the importance of defining the event and thinking about the probabilities of the event. So, event definition, it's difficult. To avoid selection bias, do not use the event exactly as observed, particularly for rainfall. So there's a tendency to just draw the box or the region rather arbitrarily around where it occurred. But So that may not matter too much when you're looking in the model world, but when you're looking at the real event, because you have seen something interesting, you might compute, oh, this is a 1 in 100 year event, but in effect you have drawn your definition of event so tightly around the one that occurred as to make it improbable. So I would just stress care out, and you will therefore find it takes time to do this, to think about what your event means in more general terms. Often we might define the event as being over some threshold, with the threshold defined from the largest event that occurred today, or to 2000, or pre-industrial. So we're looking at classes of an event, with an observed event being part of that class. And we also need to consider the region too. Ideally, one might think about, in particular if you know a climate system in that, and the weather in that part of the world, as existing knowledge might tell you that this region is a homogeneous climatic region. It tends to get the same weather at the same time. For example, in China, part of that definition would, I think, include the normal progress of the summer month, May use it front. So if we don't think about models at all, what might we expect? So if circulation is unaffected by climate change, and I suspect for the two of the events you're looking at in this workshop that won't be the case, what might we expect? Warmer world would imply the same circulation gives higher temperatures. So world is warmed, background is warmer, same circulation, we're going to be a bit hotter. And a warmer world also has more evaporation, so the same circulation will dry out the soil faster, which in turn will lead to higher temperatures. So warmer worlds we might expect to have hotter extremes, and the variability is a little bit enhanced because of those two processes. That's a rather Western European view. I know in China, because we've looked at it, actually we don't get the soil drying out type of extreme events we do in Europe and North America. Instead, there are processes involving circulation off the South China Sea and the Pacific Ocean. Climate change also slightly increases long-term rainfall, 2 to 3% per Kelvin warming, and extreme rainfall about 7% per Kelvin. Same circulation, therefore, you'd expect to give more extreme precipitation and a slight increase in monthly scale rainfall. I will note that if circulation is unaffected by climate change, and actually I think what we're finding for rainfall is that circulation is affected by climate change, and so that actually is what's the driver. That's something to think about.